Okay, hello. This is ACT worksheet 213, matrices. So out of 60 problems, you're only going to get one matrices problem. And it could be addition, distribution, subtraction. Those are probably the most straightforward ones. They're very intuitive, and I'll show you those. So like the intuitive matrices problems, even if you've never seen a matrices before, and a lot of people haven't. It's not tested on GCSEs, but the intuitive ones that are pretty straightforward are kind of addition and subtraction, distributing across numbers. So like distribution, right? Um, what's not as intuitive are some of the word problems. Specifically, you have multiplication, and then you have word problems that usually deal with multiplication. And then there's something else called the determinant. So these three other things we'll spend more time on in this video, making sure you understand them. And the best advice I can give you is there aren't tons of multiplication problems on this packet, but it's definitely something you want to know. So if you feel like you don't understand it at the end of this packet, just type into Google matrices multiplication problem worksheet, or maybe go to Khan Academy, but get more practice. Make sure you feel comfortable doing it, because it does take some repetition, matrices multiplication. But let's look at the intuitive stuff first, and we'll look at it real quickly. So these brackets represent a matrices, and we have 8 and 6 and 11 and 20, and it says add. So it's the 8 just goes with the 11. Each number, when it's addition or subtraction, just matches up with its same place. So we have 19, and then 6 plus 20, 26. Makes sense. With distribution, for this one, if you look at it, you distribute the 2 to all 4 areas. So what it actually becomes is 8, 10, 14, 16, plus 1, 9, 3, and x. And if you look at the answers, 8 plus 1 is 9. 10 plus 3 gets you 13 right here. 14 plus 9 gets you 23 right there. And 16 plus x in the bottom right corner. So each number still matches up with its equivalent in the matrix next to it. Okay, so that all makes sense so far. Let's look at matrices multiplication. So this probably looks like there's a lot going on here. I'll break it down. You can always go back to and read through the steps, and then things should also make sense. But whenever you look to multiply matrices, you always have to check the rows and the columns of each. And it will make more sense why we do this in a moment, but just kind of stay with me. So we have 1, 2, 3 rows, 2 columns on this first one. And on the second one, it's the opposite. We have 2 rows, 3 columns. Okay, so the middle bit, this 2 and this 2, tell you that your matrices is defined, that it will work, that you can multiply these by one another. Again, that may not mean much right now, but I'll show you why that is in a little bit. The outer bit, the 3 and the 3, tells you that your output is going to be 3 rows by 3 columns. So it's going to look like exactly what the output is here. Now, here's how we actually do it. We take the first matrix and we take the first row. And this first row has to make its rounds to each column. So we go 9 times 1, 8 times -4, and then we add that together. So we have 9, -32. That's going to get us -23. And that's what this is showing us right here, is that how we get this -23. So now we filled the first spot. We have to fill the second spot now, and then the third spot, all with this first row right here. So we go 9 times -2, 8 times 5, that's -18, 40. So we're going to end up with 22. And that's what's being shown right here. Essentially, each one of these is showing you how we got each one of these. All of these match up with their equivalents. Then 9 times 3, 8 times -6, 27, -48. Add those together, right? 27 minus 48 gets us -21. Okay, so what's happened here is we've taken this top row and it's visited each one of the columns. It doesn't have any more columns to visit, so we've completed the first row of our outputs. Now we literally just go down to the next row right here and we do exactly the same thing. We have to visit each column. So 7 times 1, 7. 6 times -4, -24. We have 7. Minus 24, -17 goes right there. Feel free to even pause the video and kind of go through what should happen next and see if you can finish this one out. If you haven't paused the video though, we're taking this row and we're just doing the other 2 trips to each of these columns. So -14, 6 times 5, 30. That's going to give us 16, and that's also shown by this. Then what we have is, does that say negative? That should not say negative. Why does that say negative? I don't know. That's a mistake. Anyway, 7 times 3, 21. 6 times -6, -36. That's going to get us -15. Now that we filled out this entire row, we go to the final row of our first matrix. The 0 is going to make everything in the bottom 0. So -5, 0, -5. -5 times -2, 10, 0, that's going to give us 10. -5 times 3, -15, 0 times 6, so -15. And again, all of this is shown here, down here. So hopefully that helps, and you can reference that. That's how you multiply matrices. If I were you, I would try this example and see if you can figure it out. You can pause the video. The answer is just below. So if you've paused, try it, see if you get it, then check the answer. There's the answer. Okay. Anyway, another important thing. So I was talking earlier about matrices, whether the rows and columns match up, whether they're defined or undefined. So this matrix is 2 by 2 in the middle, meaning we can do it. And the output is going to be 3 by 3, based off of the outer 2 rows and columns, right? 3 by 3. And if you look at this first row, 5 times 2, 2 times 3, 10, plus 6, 16. And then we can continue to make the rounds, right? If I just finish this first one, 25, 2 times 6, 12, 25 plus 12, 37. 5 times 1, 5, 2 times 2, 4, that's 9, and then you add them together, and then we would just do the same with these. But anyway, watch what happens on this one that's undefined. So because these don't match up, when I try to do this first row, 8 times 0, 0, 3 times 5, 15, and then there's a 4 here, but there's not a third number here. So because there's no third number, it's undefined. We cannot multiply these matrices by one another. What we would need to have is we would need to have another column, right? Then these would match up. If I had like an 8, 2, and a 1, then I could go 8 times 0, 3 times 5, 8 times 4. But because that column doesn't exist, the internals don't match up, and that means we can't do it. Okay, let's try some matrices problems. I'm skipping over the addition and the distribution ones because I figure those probably feel okay for you. Here's a multiplication one. Feel free to pause the video and try it. I'd say after I usually teach students matrices who've never done them before, about half are able to pick this up. So you'll have to see whether you're someone who picks it up quickly or whether you may need some more practice. Anyway, first thing I'm going to do, if you haven't paused the video, is rows, columns, rows, columns. What I'm going to get is I have 2 by 2, and then rows I have 2, columns I have 1. What this tells me immediately is that I can do it. Well, obviously I can because none of the answer choices are undefined, but just academically I can do it. And my output is going to be 2 by 1, meaning 2 rows, 1 column. What does that mean? A, B, and C are all gone that fast. Okay, let's actually do it. 2 times 2 is 4. -5 times -1 is 5. Add them together, and you get 9. Now we drop down because there's nothing else for the top row to do. -3 times 2, -6, plus -4, -10. So this one's going to be E. Okay. Here, see, pause this one and see if you really understand defined versus undefined. If you haven't paused, now's your chance. Otherwise, it's going to be too late. Okay, I'm just going to straight up show you the right answer and why. X times Z or Z is undefined, depending on whether you are British or American. Or something else. If you're something else, you probably say Z, I imagine. But anyway, if I do these, that's Y by Z. X by Z is this one by this one. Well, this is 2 by 2, rows by columns. This has rows, 3 rows, 2 columns. These don't match up. It won't happen. And if I try to do it, if I try to actually multiply it, 3 times 5, 9 times 2, nothing to multiply the 3 by. So that's why that one's Z. I hope that clicks. Okay, 2 more problems. So there's something called the determinant, and it's explained here, but they won't always give it to you. So I'll explain what it is in a second. For what positive real value of k, if any, is the determinant of the matrix this equal to k? Okay. And they say the determinant is when you go on diagonal. So A times D minus B times C. So you just go diagonally, multiply them, and then subtract the diagonal in the other direction. So if you reread what it's saying, and again, feel free to pause if you want to try this one at this point. But if you reread what it's saying, is the determinant of the matrix equal to k? So the determinant is going to be k times k. That's the first diagonal. That's your AD. The second diagonal is going to be 3 times 4. That's your BC. So that's 12. And it has to be equal to k. Couple options here. Now you could just plug in answer choices and see what makes this balance. Or if you're more traditional with your algebra, you can move this k over and create a binomial. Let me move my face out of the way. So we're saying, okay, that's going to be k minus 4 times k plus 3. Right. Those are going to multiply to -12 and add to -1. So if you look at it, the 2 answer choices are 4 and -3. So the one that works for this problem is going to be B. All right, one more problem. This is the hardest type of matrix problem you'll have. It's multiplication and it's a word problem. I warned you about it at the beginning of the video. So you can't say I didn't give you the heads up. Anyway, if you want to try it, take a moment to read it and give it a shot. Otherwise, I'll read it and I'll show you how to do it. So Valley High School and Mountain High School have decided that selected students will attend a daytime theatrical performance that costs $5 for each teacher and $3 for each student. 1 teacher and 10 students from Valley High will attend. 2 teachers and 25 students from Mountain High will attend. Which of the following matrix products represents the ticket cost in dollars for each high school? Okay, a lot going on. Here's the thing though. If you follow the rows by columns, D and E are gone immediately. 5 times 1, nothing to multiply the 10 by. And if you think about it, rows, columns, this is 2 rows, 1 column. Rows, columns, this is 2 by 2. These middle ones don't match up. So D and E are undefined. You can't even do them. So that's going to make our life a little bit easier. At least, if nothing else, we have a 1 out of 3 chance of this one. So let's think about this. If we have, so we're going to know which of the following matrix products represents the ticket cost. So if we think about it, the cost for the first school, for Valley High, it's $5 for teacher, 3 for student. Valley High has 1 teacher, so that's $5, right? 5 times 1, and 10 students, so that's $30. Add them together and you get 35. So that's Valley. if we look at Mountain, Mountain's going to cost 2 teachers at $5 a teacher, so that's $10. 25 students at $3 a student, so that's $75. So Mountain's going to be paying $85. So let's see which one kind of represents this. I'll tell you right now, it's going to be A. I know I kind of ruined it, but I'd rather you just understand. So 5 times 1, that's $5 for one teacher for Valley. So that gets us this 5. 3 times 10 gets us the 30. That gets us the 35 output. By the way, I should have done this. Rows, columns, rows, columns. Rows, we've got 1. Columns, we got 2. 2 by 2. Our output, rows, columns, is going to be 1 row, 2 columns. And how did I know that? I knew that because the outers were 1 by 2. So 1 row, 2 columns. So for the first school, they're going to have to pay $35. The second school, $5 for $5, 2 teachers. That's $10 for the teachers. $3, 25 students. So that's $75 for the student. Add together, Mountain High School is going to have to pay up $85 if they want to see the show. Okay, I hope that makes sense. Good luck with matrices. Again, it's going to be 1 problem out of 60 on the test. But as always, if you're able to get the problem right and you're willing to put in the time right now, then you might as well keep that point for yourself rather than give it to the test. All right, anyway, good luck and feel free to come back for any more videos.